So, hi everyone. Yeah, if you are watching this video, I guess you want to learn Zig, and probably you've heard about it or you've not actually heard about Zig before. But more importantly, you want to know what Zig is, and um, and maybe you probably have written Rust and you want to put to Zig. So this is a good place for you to be. Um, so I started writing Zig last year, and it's was quite interesting to see it like walk through examples and exercises around it. Also build some projects in Zig. I think yeah. So Zig is quite new. I'll say it's recently new. Let's backdate back to like 5 years ago, according to the commits that I've seen in the repo. I might be wrong. I hope I am not. So Zig is a modern low-level general purpose language. So, and the thing is, most programmers think about Zig as a better version of C. And so I like that the author's personal interpretation was that Zig is tightly connected to less is more. That is, it's a modern language that's trying to introduce something similar to Go, whereby you add more features to a language, but with less um, maybe less keyword, um, less keyword. Let's say, for example, if you look at C++ has I think over um 35 operators. I think you have to know every one of them. There are different constant expression. So it takes a while to learn C++, but Zig is trying to bring bring um programmers to the point that they can write faster code with less features. So Zig tries to like simplify language and make it more consistent, like and have robust behavior. And the interesting thing is that debugging is quite easy and simpler in C in Zig than it is in C and C++. I think recent I think there's a recent features of C++ is now introducing things that are present in maybe a close relation I like Python Sprint. I think I saw that recently, but that's an aside note. But we're here to learn Zig. So Zig, the philosophy of Zig is for you to like focus more on debugging in your application rather than debugging your programming language knowledge. And that's a diss to C++ because C++ is quite gigantic and it's also complex, quite complex. I did write C++ for a while. One thing that I would say is C++ build system is one of the reasons why I really didn't learn much about C++. I just use it for like when I feel like writing C++, I just write it. But Zig has something new. Zig comes with a build system, and apart from coming with this system, you don't. With this build system is enough for you. You could even use Zig's build system to compile C++ and C code. And that's a huge advantage. So if you instead of going to go and learn something entirely new like CMake, you don't need to learn CMake or Make if you want to. Make is quite light. So and Zig doesn't have macros, so you can really write your code and you won't have to you won't have to think too much about what the macros are actually doing, which is something that C has. And also Zig is also fast, quite fast. So I think that's more like the introduction to Zig. So the next thing is Hello World in Zig. Hello World in Zig is quite simple. If once you have Zig installed in your system, which you can take a look at Zig zig.org. Yeah, should be this place. So You can check documentation. If you go down a bit here, you can see the download button. For mine, I'm using Mac with Arc 64, so you can download and install it. And if you want to use Brew install, you could also use Brew install. I think there's a Brew install up there. It's been, yeah, from Zig Packet Manager, you could install it from that too. So I don't know too much about Windows, but there's a probability you might have some issues with some operating system. So that's how to install Zig. I'll put the link in the description so you could check it out. Okay, so going back, so Zig, and to start a Zig project is quite easy. You just need to create a folder and just do some Zig in it. So it initializes your project for you. You get a build Zig, a build Zig.zone, and you also have a like a main.zig and a root.zig. I'll explain what those files do in a bit. So that's essentially what we're going to do. So let's try and get that done. Then I take a look at the next step, and I'll explain more on it. So let's say we have an Hello World project. So it's just I'm using VS Code by the way. Uh, if you're a fan of Vim, I'm not too much of a fan right now. Probably learn later. I do use it once in a while. So you can just cd into Hello World, and then you can just zig in it. So you get this file created for you. So let's take a quick look at the file. So we have a zig dot email.zig, and if you check it, we have a public main which we can run. Then we have a couple of tests underneath, which is a simple test. Zig allows you to write the same test. You can write the test inside the same file with your programs. So another one is the zig dot root.zig, which is more for like when you want to create or when you want to create like things you can export, like static libraries and dynamic libraries. You could, that's where you can add some parts of the code. Okay, so the next one is build.zig. So these are build section, like our build file. So once you check anything here, or once you add new files to this whole project, you have a build. You have to run the build.zig to build it, and then you get like an output file zig out where you find the executables and you can run it. Then you have build.zig zone, which is more like a package dependency manager. So if you add new dependencies, it will be added to this place in form of like the hash and the GitHub, maybe the repository it was added from. So it will be pulled down and you can compile that together with your own code. So the next thing is, I think, understanding the whole project. That's basically understanding the whole project. I was fast with that. So if you go through this book, it is online. I'll add the link. You'll see that we have a main.zig and a root.zig, and then the main.zig module is where your function live, your main function, the entrance to the executable program when you write zig is in. So the next one is the root, which is the root module. It's more like the root source of your library. So you are building like static libraries or dynamic libraries, or you want to interact with low level languages. So you can use the compiler to build your source into the binary executable, the binary library. So the thing is, there's cross compilation. Zig is cross compiled. You can add some target machines that you want to like build for right through the build.zig file. And the reason for build.zig is to like save the time of going to go and learn like CMake and Ganymake and maybe Ninja. I think there are as much as, but I'm not too sure. I think Bezier is also a build system too, but I won't be too sure. because I don't really have experience writing Bazel. So the next one is I've experienced it on which is Zig's package manager configuration file, just like you have for npm, which you have package.json. This is the same one for Zig. And then the root file, I it took like explain that in a bit like a while back. One important thing to note is that there's something called std.import, which is the way to bring Zig's entire standard library into your project. And then you can export a function which like a library in C can pull in and use. It's usually for like you trying to like export code written Zig to other languages. So they could use it other languages. By other languages, I mean C and C++. So Zig is strongly typed as like in the course of like learning this, you see that Zig is strongly typed. Every single variable has a type. And then there's some specific situation where you might omit type you're allowed to, and it will be inferred by the compiler. So there is implicit and explicit um, um, declaration of variables. And the way you do that is let's take a quick look at no, we don't find it there. Let's just look at this. You see that we have like a colon I32. I32 has a type. Y is the variable. So a bit further, we'll start identifying things like constant variable, variable that can change, and so on. So we also have like export keyword here, which is for like exporting this function to an external. Like you can expose it. Expose it is just the same thing as using extern in C, which allows you to pull in like libraries, like functions, and make it available to as a library API. So, for example, in this particular code, this add can be exported. So, the main I've explained that. So let's quickly take a look at the main code. The main code has like print. There's a debug.print which you can strip off later. On we'll see that you can strip it off using one of the build commands and strip it off. Then that's if you are running in a production environment and you don't need to write the logs as to the std out or std error, whichever one you're working with. So here we have std out file, which is more like our standard output file where we want to write to say we are using a command line. So we can write to that part. And then we have a writer. There is going forward you will see that it doesn't have some things that come with other languages, but it's pretty much there. Further research into Zig library will allow you to understand more about how this those interfaces, something like interface, for example, are used or written. So if you check closely, you see something called std import at import. And if you're familiar with JavaScript, you probably understand that import, or if you're used to write Python, I think this is something that brings you closer to like understanding importing in Zig. And in Zig's importation is quite simple. Maybe the guides and rules for like importing things are not yet like defined, but you could always form your own pattern, or you can take a look at projects that have been written, bigger projects that have been written that have the patterns that you can pick up from. So this is an std out, which is the standard output. And we have a buffered writer, which it makes like writing to the standard output better, improves it without writing everything in memory. So we have standard out, and we can just print to standard out through std_out.print, which is equivalent of the buffer writer wrapped around our std out file. So then we have flush, which simply just flushes it to the std out stream. So that's exactly what it does. But then, if you look at another thing now, as an introduction, there's something called try. Is how Zig handles error handling. So a try method, there are other ones like try catch. There are other ones that you can just return the error to your power layer. So going forward, you'll see that part. So if you do run this code, we will see that our Zig, we're going to get like a couple of things written. And so we have all your code base belongs to us and run zigw to test this. So this is exactly what it does. So, and how did it actually do this? A simple example, a simple explanation for that compared to when I use VS Code to directly run it is by going directly to our CLI terminal, then write Zig. If you press Zig and you press enter, you see a couple of commands that tell you how Zig works. So for to compile the code, you can just do Zig build exe and then you can just source slash main.zig. And the reason is because you are running just the main.zig. And if you check closely, you see that we have you see we have a main, right? Now the issue here is that root we in Zig we are trying to import. We have main.zig, then we're trying to import root somewhere, so it won't work because our standard library doesn't know where that root file is coming from. And if you go to Zig, build Zig, you can scroll down and we'll see the reason for that. So we have root importation here. I'm bringing it in from the standard library, from this part. I'll bring it in. I'll explain the zig.build in a bit, like maybe subsequent videos. But the reason why we have the error is because we added the we have an executable that we need to build for the root. Okay, so going further, you can write you could build a library by using b.lib, and that will run our root file and build it for us. And the same thing you can build that to an object on your library depending on what you want to do. It could be then you can compile your like our Zig module into a portable C API library, respectively. Kind of. Since Zig can interact with C can interact with Zig, so that makes it worth your time. So essentially, the important files are coming a little bit into hello. Important files are zig.zone and the C and the source folder. So if you want to run everything at the same time, you can just do zig.run zip run src/me. And the reason why it doesn't work is because there's no main.zig. Now we are building, and you see that we have all our code base belong to us. That's why. So so before I said that there are some things that are different for Windows and for Linux users. So example is like there's an important note for you Windows users. I'm sorry if you use Windows. Kind of happens one of this one of like those times like that. It happens like that. You have to go extra mile to fix some things. So if you have like a piece of Z code that includes some global variables whose initialization depend on the runtime resource, then there might be like a couple of problems with that. So in that case, for example, if you use our std out standard output, so you could use std.io.get out in Zig, but if you use this expression to instantiate the global variable in Zig module, then the compilation of your Zig code is very likely to fail on Windows. And that's for Windows because it might fail. So this failure of the compilation is due to like the use of global variables in Zig app initialize and compile time. So going forward, we're going to see the difference between compile time and during runtime. So compile time are like code code optimization, compression and stuff that happen during compilation. So as soon as we continue to like practice it, you start noticing some pattern there. So another thing is compile the entire project. You can just write zig.build and it builds the entire project into one binary. You will see it over here. There's a zig out. So you can see it creates a whole folder with even a library because it was specified in the build file. So how do you learn Zig? Although you are learning Zig through this video, but you could also go through like you can go through like Reddit, Zigit community, the ones on WhatsApp, the ones on Slack, and then you can go through like large code bases like TigerB2, Clap, and Event Loop like libxev. So it happens for such case in such cases like that. So another way to practice is you could use Zigling, and some people go for Advent of Code. I don't think I did that, so Advent of Code is also one reason. And you can also check out Primegen. He has some resources on that too. So for now, that's entirely what we'll be looking at. So in the next section, we'll start identifying new objects in Zig. Like, okay, how do you create like a variable? What are the rules for creating a variable? All right. Yeah, see everyone next session.